Hi, welcome to this tutorial about mutually exclusive events. In this session, we are going to understand and identify mutually exclusive events, and we are going to calculate probabilities of mutually exclusive events. Before we do that, I need you to warm up. So here are some questions for you to do. They're just quick questions, so please pause the video and come back in a couple of minutes to check the answers. Right then, so hopefully you've gone through the questions, and here are the answers. First one, what's the probability of getting a 5 when you roll a dice? Well, there are 6 outcomes on a dice, and there's only one 5, so the answer is 1 out of 6. Probability of getting a tail when you flip a coin? Well, total of 2, and there's only one tail, so 1 out of 2. What's the probability of picking a blue counter when there are 2 blues and 3 greens? Well, in total, there are 5 counters and only 2 blue, so the chance is 2 out of 5. What's the probability of getting a double 6 when you roll 2 dice? Well, so that means you want probability of getting a 6 and a 6. Okay, so when we say and in probability, we multiply their probabilities. So probability of getting the 6 on the first roll is 1 out of 6, and probability of getting a 6 on the second roll is the same, 1 out of 6, so that gives you 1 out of 36. Right, what's the probability of getting 2 heads when you toss a coin twice? So again, we want probability of head and head. So head and head, and we multiply probabilities. Probability of getting the head is half, and again is the same coin or similar coin, so you get 1 out of 4. Hopefully you got those right. Right, so what does mutually exclusive mean? It just means that something that cannot happen at the same time. Okay, mutually exclusive events cannot happen at the same time. And then just make a note of this formula, which we might use later on. But you need to know probability of something of A or B happening. Then you need to add their probabilities. Right, here are quick questions for you. So what do you think? Let's have a look at these scenarios and see if there are mutually exclusive events or not. Teaching at school and sleeping at home at the same time. Well, I wish. Definitely is not going to happen. So we say these scenarios here are mutually exclusive events. They cannot happen at the same time. Having toast for breakfast and having pilau for dinner. I don't see anything wrong with that. I can have toast for my breakfast and I can have pilau for my dinner. So these ones are not mutually exclusive events. They can happen. Getting the bus and missing the bus at the same time. That's a dodgy one. Well, I don't think this will happen. So these two scenarios can not happen at the same time. There are definitely mutually exclusive events. Watching a comedy DVD and watching a romance DVD. Well, I normally people watch one movie at a time, right? So these are mutually exclusive events. Being hungry and full at the same time. I'm not sure about that. Well, I don't feel hungry and full at the same time. Unless there's a problem with my stomach, I will say this one is a mutually exclusive event. I cannot be hungry and full at the same time. All right, let's do some examples. Question 1. In a box of cupcakes, there are strawberry, vanilla, and chocolate flavors. The probability of choosing a strawberry chocolate is shown in a table. So these ones. What is the probability of choosing vanilla? So we need to find this one. So probability of, I would say, strawberry plus probability of chocolate plus probability of getting a vanilla, they must be 1. Okay, so strawberry is 1 out of 6 plus chocolate is 5 out of 12 plus probability of vanilla flavor, I don't know, but I know everything must be equal to 1. Right, let's add these two. We need to have the same denominator, so that's going to be 12 out of 12. What? 2, sorry, beg your pardon. 2 out of 12 plus 5 out of 12 plus this one must give you 1. So if we add these, we get 7 out of 12 plus this. Rearrange this, then you get probability of getting a vanilla flavor equals to 1, take away 7 out of 12. And just in case you can't remember your fractions, probability of vanilla flavor equals to, well, we need to have the same denominator. This is the same as having 1 over 1, so that's 12 out of 12 minus 7 out of 12, which will give you 5 out of 12. So probability of choosing a vanilla flavor is 5 out of 12. Right, question 2. On a Saturday evening, Amy chooses from 4 different activities. She's equally likely, so let's just make a note of that, to go to the cinema or bowling. Calculate the missing probabilities. So we know this chance and this chance are the same. Again, so we don't know what they are. If we just call them X and X for now, okay? So that means we need to add X and X. If we add all these, sorry, the X should be here. We know that's 0.3. So X plus 0.5 plus X plus 0.3, everything must give you 1. Okay, so let's add these. X plus X is 2X. 0.5 plus 0.3 is 0.8. That's equal to 1. So 2X equals to 1, take away 0.8. 2X is 0.2. Therefore, X is 0.1. So each one of these probabilities is 0.1. The chances of going to bowling is 10%. Right, question 3. From a bag of sweets, I could choose strawberry, blackcurrant, or orange. Write an algebraic expression in terms of X for the probability that I choose orange. Okay, well, I don't know what this is, but if I add them all up, I should get 1. So if I do 1 take away these 2, I will get that answer. So probability of getting orange is going to be equals to 1 take away 2x take away x, which is 1 take away 3x. So that's what it is. Okay, and that question is done. Right, last question now. In a bag of counters, all of the counters are blue, green, or purple. Calculate each probability as a fraction. Okay, so this time we need to find the actual probabilities. We just got x's in there. So what this means is probability needs to add up to 1. So probability of blue plus probability of green plus probability of purple, they must be equal to 1. And now I know them in terms of algebra. So if I do x plus 3x plus 2x must be equal to 1. So x plus 3x, 4x plus 2x is 6x, and that's equal to 1. That means x is 1/6. Right, I need to find the actual probabilities. So this one, x is just straightforward. Okay, so for green, is 3x, so 3 times 1/6, which will give you a half. So this probability is a half. Okay, let's just put it like that. We're not saying 3x equals half. And similarly here. So 2x then, that's for purple. So 2 times 1 out of 6, this will give you 1/3. So this probability is 1/3. Right then, here are some questions for you to try. The ones which are crossed are the ones that we just did, so you try the rest. And once you finish, please take a screenshot of this, and you can take a screenshot of this to check your answers. And thanks for watching from Teacher Raya.